Locus, in Latin, is a word that means place or region. The plural of locus is loci or loci. When we talk about locus in geometry and mathematics, we are referring to a set of points that share a property. In other words, a locus describes a figure or a graph which follows certain rules. Activity 1. Draw the locus of all points at 15 millimeters from line R. This is line R, and we have to find out the shape of the figure which follows that rule. To find 2 points at 15 millimeters away from line R will be very easy. We just have to construct a perpendicular line at any point. On this perpendicular line, you will measure 15 millimeters on either direction, 15 millimeters downwards. You will get that point. I'm going to call this point P, P1. 15 millimeters upwards will be here. You will get point P2. The question is, these 2 points, P1 and P2, they both satisfy the condition to be at 15 millimeters from line R. The question is, can you find all of them, all the points on the paper sheet that fulfill that property? Imagine you continue making perpendicular lines to line R, finding points M1, M2, T1, T2. What you are going to see eventually is that you would have 2 parallel lines. So, how to solve this activity? Once you have points P1 and P2, you construct a parallel line to R going through point P2. This is one of the possible solutions. And then you will construct another parallel line going through point P1. So these 2 parallel lines are the locus of all points at 15 millimeters from line R on the plane of the paper. Activity 2. Draw the locus of all points at 25 millimeters from point P. That is, we have to find points at 25 millimeters from point P on the paper. So to find just one point is something pretty simple. You will just have to set the 0 on point P and you will measure in any direction. Okay, let's take this one. 0, 25. All right. This point M is at 25 millimeters from point P. If you continue finding points at 25 millimeters away from P, you will quickly realize that what you really have is a circle. The circle contains all the points from the paper sheet at a distance 25 millimeters from the point P. This is the reason why we define circle in the plane geometry as the locus of all points that are at a certain distance from a central point, the point we called the center of the circle. Activity 3. Draw the locus of all points at 8 millimeters from circle O. I will draw the radius of the circle and I will name it R, the radius at any point, for example here. Okay, this is radius R and this is point P. I'm going to extend the radius a little bit. Okay, on either side of point P, I will measure with the ruler 8 millimeters. So 8 millimeters in this direction, 8 millimeters to the right from P, 8 millimeters to the left from P. These 2 points are at 8 millimeters from the circle. Circle is point P. If you keep on finding points with this procedure, you will eventually realize that the shapes described are two concentric circles. The first one, or the smaller one, will be radius r minus 8 millimeters. And the larger circle will be radius r plus 8 millimeters. So this is the locus of all points at 8 millimeters from circle O, and this is the locus of all points at 8 millimeters from circle O. Activity 4. Draw the locus of all points at 10 millimeters from lines R and S. Straight lines R and S, they are intersecting lines. All the points at 10 millimeters from R will be contained in parallel lines 10 millimeters away. So it's a very similar situation to the case number 1, but we have to make this construction twice. One for line R, another one for line S. And this is exactly what I'm going to do. I'm going to find a point 10 millimeters away from R. How? Well, constructing the perpendicular line. The perpendicular line is the only way we can really make sure that we are measuring the distance properly. So this line is an intersecting line at 90 degrees. I'm going to measure from that point on either direction 10 millimeters. Okay, that will be point P1 and P2. And I will be able to construct the parallel lines to R, just making parallel lines with a set of squares that go through point P and through point P2. All right. These two lines contains all the points of the paper sheet at a distance 10 from line R. Let's see, where are these two parallel lines for the straight line S, which is this one. You construct a perpendicular line to S at any point. You measure on either direction 10 millimeters. 10 millimeters is 1 centimeter. You get points M1 and M2. And then with a set of squares, you draw a parallel line that goes through M1, and another parallel line that goes through point M2. All right, these two straight lines contain all the points of the plane at 10 millimeters from line S. If you realize there are 4 points where these parallel lines intersect. This point here, I'm going to label this point A, this point there, point B, point C, and point D. Points A, B, C, and D are the locus of all points at 10 millimeters away from lines R and S at the same time. Activity 5. Draw the locus of all points at 12 millimeters from line R and point P. This activity is a combination of activities 1 and 3. So we have to find all the points at 12 millimeters away from the straight line R, and then all the points at the distance 12 from the point P, the point where these two constructions meet. We will get the solution. So the first thing I'm going to do is to find all the possible points 12 millimeters away from this line. I will construct a perpendicular line . I will measure on either side 12 millimeters, point M1 and M2. And this is the locus of all points at 12 from line R. All right. All the points at a distance 12 from point P are in a circle radius 12. So I'm going to measure 12 millimeters somewhere. Okay, this is going to be radius 12. And I will construct a circle. Where the circle meets the parallel line, you will find the points that satisfy the condition to be at 12 millimeters from line R and point P at the same time. That is, point A and point B are the solution of this activity.